Hello everyone, this is the Space Speaker coming back to you, and today we are going to be going over the star VY Canis Majoris. Now VY Canis Majoris, or just Canis Majoris, is a high luminosity M star with an effective temperature of about 3,500 K, placing it at the upper right hand corner of the Hertzsprung-Russell diagram, and meaning it is a highly evolved star. During its main sequence, it would have been an O-type star, with a mass of 15 to 13 meters. In 2006, the University of Minnesota professor Roberta M. Humphreys used the spectral energy distribution distance of Canis Majoris to calculate its luminosity. Since most of the radiation coming from the star is reproduced by the dust in the surrounding cloud, she integrated the total fluxes over the entire nebula and showed that Canis Majoris has a luminosity over 5.6 by 10 to the power of 5. Most recent estimates of the luminosity using a variety of methods give lower values of around 3 to 10 to the power of 5. Humphreys' original estimated the radius of Canis Majoris at 1,800 to 2,100 solar radii. A radius so large that it places it outside the bounds of stellar evolution theory. A more recent accurate VLTI measurement gives the star a radius of 1,420 to 120 solar radii. Earlier direct measurements of the radius at infrared wavelengths gave values above 3,000 solar radii, but this is probably larger than the size of the underlying star. In 1967, Charles J. Latta and Mark J. Reed published a discovery of a bright-rimmed molecular cloud and 15 minutes of arc-east Canis Majoris. At the edge of the cloud, bordered by a bright rim, an abrupt decrease of the CO emission and an increase in brightness of the CO emission were observed, indicating the possible destruction of molecular material and enhanced heating and cloud rim interface. Respectively, Latta and Reed assumed the distance of the molecular cloud is approximately equal to that of stars, which are members of the open cluster NGC 2362 that ionized the rim. NGC 2362 has a distance of 1.5 to 0.5 kiloparsecs. As determined from its color magnitude diagram, Canis Majoris is detected projected onto one of the tips of the cloud rim, suggesting its association with the molecular cloud. In addition to that, the velocity of the molecular cloud is very close to the velocity of the star. This further indicates the association with the star with the molecular velocity of the star, and consequently with NGC 2362, which means Canis Majoris is at the same distance. A more recent measurement of the distance of NGC 2362 gives 1.2 kiloparsecs. Stellar distance can be calculated by measuring the parallaxes as Earth's orbit around the Sun. However, Canis Majoris has a tiny parallax due to its great distance. A standard visual observation, such as Hipparchus, have too great margin of an error to be useful. VLBI measurements of the parallax of VY Canis Majoris using H2O or water masers are much more accurate and give a distance of 1.14 kiloparsecs. VLBI measurements using SIO masers give a distance of 1.20 kiloparsecs. The Gaia emission should provide visual parallaxes with even better accuracy. Now, guys, I'm sorry for a few of the stutters there. I am tired. I woke up like a few minutes ago and I have church this morning, so that is why I was stuttering for a little while. I hope you enjoyed this video on Canis Majoris. It is a star that I really like to study because it was known as the biggest star in our universe for a little while, guys. So I thought it was pretty interesting. So thank you guys for watching. Please subscribe, like, and comments if you will. Please consider subscribing and leaving a nice comment or a like. And if you do leave a comment, please a suggestion on maybe a new star or a new cover up that I haven't done yet. And yeah, so thank you guys for watching. Safe travels, searchers.